Hello academics, welcome back to the channel. Today we are going to be learning about finite differences. This right here is a topic that's a little more complicated. And to be fully honest, will you ever use this in real life? No. But is it important to know? Yes. Because there's deeper topics that will need this base knowledge. So it's important that you have a good understanding of it. But again, it's a little boring. It's a little repetitive, but you just got to know it. Well, to start off, you might be wondering, what is the point of finite differences? Well, there's two main points. The first one is to find the degree of a polynomial. This might be a little straightforward, but when you just have a data set, it's a little more complicated than it seems. So for example, in 2x to the power of 6, the degree is 6. And the second point is to find the leading coefficient. And again, for example, 2x to the power of 6, this would be the 2 right there, right? So it's just to find the degree and the leading coefficient. And you might be wondering, how do we do that? Well, that is done using the principle that for a function to the nth degree, there will be a constant nth difference. If that doesn't make too much sense now, don't worry too much about it. We're going to go more in depth into that later. But for now, it's just important to know that that's a possibility. And so we're going to do that using the equation. This is the only equation that's important today. The equation that the nth difference is equal to the leading coefficient, which is just a, so I'll just put lead coefficient, times the degree factorial. So let's move on from that. We'll do our first example here with the function of negative 2x to the power of 3. So to do the finite differences, we're going to just look at this here. We're going to look at each one here, and we're going to find the difference in between the terms. So right here, that's negative 38, so 16 minus 54, and then this 2 minus 16 is negative 14, 0 minus 2 is negative 2, and then negative 2 minus 0, and then I'll just keep doing this for the rest of them. Just like that. And then next up, we're now going to do the finite differences of these ones. So right there, that is 24. And for each one, I'm just doing the same subtraction, but I'm going to start doing them a little bit quicker here. So we keep moving along. Oh, those were negative. And then there, so that gives negative 12, negative 12, negative 12, and negative 12. And then we can see, once we got to, so this is the first, this is the second, and this is the third. So the third difference, we have a constant difference there because it's negative 12, right? So that tells us that our degree is going to be 3. And then we can use our formula from earlier, which is the nth difference is equal to a times n factorial. So we'll isolate for a, so that just gives us the nth difference over n factorial, which gives us negative 12 over, which is 3 factorial. And if you don't know, that's just 3 times 2 times 1, which is negative 12 over 6, which gives us negative 2 as our leading coefficient. So just from this table, we were able to determine the degree and the leading coefficient. And if we look back at our original example up here, we can see that's exactly what it was. The degree is 3 and the leading coefficient was negative 2. So this was a success, but we're going to do one more example just to make sure that we understand it well. And so for this one, I'm going to give you guys a chance to do it first. So pause here and try to do it. And then after that, I will give you guys a solution. Okay, so now we're going to work on the solution here. So I'm going to do it a little more quickly just to see if we got it understood. But if you have any questions, feel free to go back to the previous example. So right there, negative 64, that 260 right there, 60, 4, negative, oh, sorry, negative 60, and then negative 260. And then our next difference, now the second, negative 200, and then negative 56, and then negative 8. Oh, it appears I forgot a minus there. And then right here, negative 56, and then negative 200. And then for next one, 144, 48, negative 48, negative 144, and then right here, negative 96, negative 96. Oh, it's looking promising. And there we go. We can see here on our first, second, third, fourth difference, we had constant terms because they are all 96. And so we know that the nth difference equals negative 96. And so now from this we can extrapolate that the degree is 4, and then we're going to use the equation right here of nth difference equals a times the degree factorial. A is equal to the nth difference over n factorial. A is equal to negative 96 over 4 factorial, which is equal to negative 96 over 4 times 3 times 2 times 1, which is equal to negative 96 over 24, which is equal to negative 4. And so from that, we know that A is equal to negative 4. So if we have both of this, we can go check back with the original equation in the top left corner. The degree is 4, and the leading coefficient is negative 4. So again, this is what the finite difference strategy is. You only use this when you are given a table of value and you are trying to find the degree and the leading coefficient. Beyond that, it is not the most useful thing. So that's why, again, I say you don't really use it that often. But to find those two things from a table of values of a polynomial function, it is very useful and definitely important for any exam or test that you'll be doing. So thank you for watching, and hopefully I'll see you in the next video.